good morning to Sir Michael. We would like to present our assignment. The title is Smart Farming System. The group members are Ho Ka Wing, Lee Fei, Lo Jun Ho, and Tai Bing Hao. First, I would like to present the background study of the assignment. Smart Farm is a modern farming system. The farm is connected to user using Internet of Things. User can monitor the condition of the farm through smart devices. The data can be monitored such as temperature, soil moisture, and etc. User can directly receive the information of the farm once the smart devices connected to the farm. If the condition of the farm had over the limit set, the smart farm system will alert user to take action. To achieve smart farming system, the platform we use is Amazon Web Services, which is AWS. AWS offers reliable, scalable, and inexpensive cloud computing services. The services we use is IoT Core, SNS, Lambda, DynamoDB, Data Pipeline, and S3. IoT Core is a cloud-based service that allows users to connect the smart devices and the smart farm system. IoT Core provides an interconnected, interact environment between the AWS services, smart farm, and end user. Next, the second AWS service is SNS. SNS is a secure and highly available messaging service that enables users to decouple microservices, distributed system, and serverless application. Then, the third service that used in Smart Farm is AWS Lambda. Lambda is a serverless compute service that allows users to run the code without provisioning or managing server. After that, the service involved in the Smart Farm system is DynamoDB. DynamoDB is a fast and flexible NoSQL database service for any scale. Lastly, the data in DynamoDB will have a backup once a day. The backup will pipe into S3. The services involved is AWS Data Pipeline and S3. Data Pipeline is a web service that can reliably process and move the data between different AWS compute and storage service, while S3 is a simple storage service that allows users to store any size of data. That's all for the background study.
Hello sir, I'm Nick Fei, and now I'll talk about the problem statement of this project. For your information, the agriculture industries are falling behind with the large demand of food due to drastic rise in population around the globe. Now, we take a look at this graph generated by the Global Harvest Initiative. It highlighted that the food production is not growing fast enough to sustainably feed the world in 2050. As we can see in the graph, the gap between the green line, which is the required rate of growth, and the orange line, the current rate of growth, were predicted to be larger and larger over the years, right? Not to mention when incident like apocalyptic outbreak COVID-19 that happened recently, everyone is required to stay at home all day. Therefore, the demand of food rises even faster. The agriculture industries might not produce livestock, poultry, fish, and crops fast enough. Nowadays, clearing more lands for agriculture purpose is a common way to overcome this situation, which is bad for the environment. Hence, this project was created to tackle the problems by using the technology of cloud computing and Internet of Things, IoT. Here are the problem statements. First, how to get rid of need of human resources when it comes to some basic operations of an agriculture farm. Second, how to keep track of environmental factors such as terrain, climate, soil, properties of an agriculture farm so that it won't affect the production. And that's all for problem statement. Now let's move on to literature review.
Okay, let's proceed to the literature review. So in this literature review, we have reviewed some of the cloud platforms such as Amazon Web Services, Microsoft Azure, and Google Cloud Platform. For AWS, it is actually a platform that offers different kinds of cloud computing services such as storage, database, networking, analytics, machine learning, augmented realities, and others. For the Microsoft Azure is a platform created by Microsoft. Microsoft Azure consists of several components. They are Azure Compute, Azure Storage, Fabric Controller, Microsoft SQL Azure, etc. These are the tools to support the development process. For the GCP, it is published by Google and most of its functionalities are integrated with end-user products and G Suite. Besides, it provides various kinds of cloud services such as data storage, data analytics, machine learning, networking, and some of the cloud AI. So among these three cloud platforms, we have chosen Amazon Web Services as our cloud platform because of its stable S3 and good pricing. So for the familiarity with the technologies, we are quite familiar with the AWS services. We can use Lambda to run our code and backend service in the background, and it will fully assist in our applications development process. So that's all for my presentations. I will pass to my team member.
I'm Gawing and I would like to continue to talk about the future work of our system. So due to the limitation on time, the system is still not suitable to be implemented into the real life. The system still has to be improved in many different ways. Besides, more testing has to be done to ensure the system works flawlessly. So these are the future work that we plan to include in the system. First is to review and revise the function of the system. In the coming future, the system can be reviewed and optimized to improve the services of the system. More services also can be added in order to let the system to adapt to the future. The next one is automated the process of harvesting. The process of harvesting the crops can also be automated. A robot armed with artificial intelligence can be implemented into the system. The robot will move around on a track that we set, and at the same time, the robot will scan for the crops that are ready to be harvested. So, in conclusion, the future work is a plan to improve the system to let it adapt to the coming future. That's all for our presentation. Thank you.